Welcome. This is our Kent USA 1340A engine lathe. Today in this video we're going to cover how to change the chuck, how to dial in a 4-jaw chuck, and how to set up a tool on center. Stick around, it's going to be fabulous. So today we're going to be replacing this 3-jaw chuck with these 4-jaw independent chucks. You're going to need one of these, and obviously you're going to need a lathe in order to do it. So here we go. Okay, so step one is we do not want the lathe to be able to turn on when we're doing this. So step one is let's press the emergency stop button, and then we are going to check by pulling on the lever up or down that it does not work. So it's all safe now. Nobody's gonna get hurt. We also want to move the carriage as far out of the way as possible, so it's not in our way. Okay, the two tools you're gonna need is you may need a dead blow, and you're gonna need the chuck key. Remember, the chuck key only belongs in your hand or in the rack, never anywhere else. So, the big thing we need to understand is this is a D-lock chuck, which means there's 3 of them. They have to be turned in order to release the chuck. Okay, we've zoomed in on one of the locking keys. You'll see a witness mark right here, and on the black part there's a witness mark over here. We need to turn those to align on all 3 chucks. So we simply take the chuck key and we are going to turn it until it lines up. Turn it to the other one, repeat the process. Okay, put the chuck key back where it belongs. Remember, it always goes in the chuck. Now this should come off if you have to shake it. Sometimes if it's on there too tight, you just give it a slight tap with the dead blow and it'll pull off. Okay, we're then going to put it over on the table and we're going to bring over our 4-jaw chuck. We need to clean this inner surface. So we're going to get a rag, make sure there's no chips, because this surface bears on this surface. And we're going to do the same thing here to make sure it's clear. And then you're just going to take these and you're going to lift it up here and you push it in. Now, the smartest thing, keep your hand on it or it can fall out. Take the chuck key and we're going to turn it like a quarter of a turn. Because a quarter of a turn will just keep it from being able to fall off. Okay, now we want to turn the locking keys counterclockwise direction because we're trying to pull the chuck onto the machine. If we go the other way, we're actually pushing the chuck off. So we just take it here, and once we've turned them all a little bit, we're just going to go around and tighten all of them up. Okay, now the chuck key is installed, and we are ready to roll on learning how to dial in a 4-jaw chuck. Okay, we have a 4-jaw chuck installed. Now we're going to learn how to dial in a piece of material into the 4-jaw chuck. So to do that, you're going to need a dial indicator, a piece of material, 4-jaw chuck, and obviously a lathe. So let's get started. We need to open up the chuck to take the material. Okay, so the material's loose in there. The best way to get started is see these concentric rings that are here. If we we just pick a point on these chucks and we're trying to line them up. So you can see here the gap between here and here and the gap between here and here are not the same. So what we're going to do is we're going to tighten this one up more to try to bring it to the same spot on all of them. Okay, and once we do that, that means it's reasonably in the center. Now I have switched this into neutral. You can see the lever is halfway between high and low. It'll make it much easier to spin the chuck, and we're going to do a lot of hand spinning of the chuck. So now that we have it kind of centered, it's close but not ideal. Now we need to set up our indicator. We're going to set it right here and turn on the magnet. So we go to on and off the carriage, and if we loosen this up, we only have to turn it about a half a turn. And we're going to bring it over and we want to bring it down so it's reading. Now I find it easiest to do if you have it straight up and down or straight horizontal, because we're going to do a lot of movement with the chuck. So now we're going to spin this, and we're going to notice it spins massively. The goal here is to get this to spin at 0, okay, or as close to 0 as possible. So the easy way to do this is I always try to find the high spot first. So easy way to pull up the high is pull this up. So it going around clockwise is going to produce the high. So that's the low, and here is the high. So we want to push this down, the cylinder down in the rotation. So what normally that means is spin it to the low, loosen it a little bit, spin it around to the high, tighten it a little bit. Okay, and we keep doing that until we get this down. So this is still extremely low, so we're going to loosen that up, tighten this up now. Oh. Now we are spinning in a small. Once we get it to within about 20 thou of rotation, now we can start working with all of them. So here once again is the low spot, so I just barely turned it, and I'm trying to get it to halfway in the rotation, which is about 15. And actually, wow, look at that, so quickly. I only had to make a few adjustments, but normally you do it, we're spinning it, what, about 1? So now we have it. Now we're just going to go through. We're going to apply a little bit of force to each one. Oh, see, that one was loose. Okay, we're going to just make sure all of them are tight. We don't want the part coming out. So I'm applying about the same torque onto each one, hoping not to adjust it too much. And there we go. Now we have a part dialed in on a 4-jaw chuck on a lathe. We have put in a part that's perfectly now cylindrical with the rotation of the chuck. And you can see it simply by rotating it. And if I turn it on, put it in high, because that's going to show, take off the emergency stop, which remember we wanted to turn off whenever we're working by hand. And you can see that there isn't a perceivable wobble on the part, so it's perfectly dialed in. Next is we need to set the height of the cutter. The tip of the cutter needs to be on center line. If it's slightly below, you're probably going to be okay, but if you're above, it's bad news. It needs to be on center line. And that is adjusted here by adjusting how high it is, and that's adjusting these 2 screws. The top one is a locking screw, and the bottom was the one you could adjust. So you're going to bring it down, and then you're going to bring the cutter beyond the diameter, like you see here, and you're going to take a ruler and you're going to pinch the ruler between the cutter and the workpiece. So you can see that the cutter is bent towards the operator. That means that the bit is too low. If it was bent away from the operator, then it would be too high. So all we do is we take the ruler out, we loosen it up, we turn this, sets this disc a couple of turns, and we repeat the process of tightening it up, putting this between here, and bringing it back. Now it is pretty straight up and down, so now the cutter is on center. Another way to test it is this way. Another method is to actually make a facing cut. And when you make the facing cut, you will end up with a little nub, either high or low, that will show you how to adjust the cutter. So we're going to go ahead and show you how to do that. So first off, we're going to talk about the quick change tool post and how to set up a tool. So this is a quick change tool post. You drop the tool in like so, and the lever, pull it tight, and now the tool's secure. If you look, we have cutters that are painted red, painted blue, green, orange, and we also have ones that are black. Black ones are universal, meaning they can be used on any of the 4 machines. Obviously, all the blue ones go with the blue machine, and all the red ones go with the red machine, green and green, and black and orange and orange. Now, within a machine, there's a very good likelihood that we're going to have 2 cutters that look almost identical. This one, it's kind of hard to tell, is gold. This one is silver. Silver ones cut aluminum and brass. Gold ones cut steel. So we don't, in sim, we don't use this one very much. You're pretty much always using the aluminum. But if we do end up cutting steel, you would switch to this one. They all go on the rack. We do have, here is an example of a specialty cutter. It's designed to do a chamfer because it's at a 45. There's a lot of times you want to put a chamfer or break an edge at the end of a part, and you're going to go use one of the black cutters that we share between machines. Okay, our next task is we need to set the cutter's proper height. The cutter needs to be aligned on center or slightly below, never above, which means we need to make adjustments up and down with this stop. So we set the cutter in, bring it down to the stop, and then that'll line us up. Now, how can we do this quickly? Well, the one way to do it is you bring the cutter out beyond the diameter of the part, you crank the cutter in, and then you take the ruler from here and you lightly pinch it, and you lightly pinch it between the diameter, of course. Next is we need to set the height of the cutter. The tip of the cutter needs to be on center line. If it's slightly below, you're probably going to be okay, but if you're above, it's bad news. It needs to be on center line. And that is adjusted here by adjusting how high it is, and that's adjusting these two screws. The top one is a locking screw, and the bottom was the one you could adjust. So you're going to bring it down, and then you're going to bring the cutter beyond the diameter, like you see here, and you're going to take a ruler and you're going to pinch the ruler between the cutter and the workpiece. And if we see here, you can see that the shaft is the, now we're looking end on, and we can see that the ruler is bent towards the operator, which means the cutter is low. If it was bent towards the so you can see that the cutter is bent towards the operator. That means that the bit is too low. If it was bent away from the operator, then it would be too high. So all we do is we take the ruler out, we loosen it up, we turn this, sets this disc a couple of turns, and we repeat the process of tightening it up, putting this between here, and bringing it back. And now we have it pretty straight up and down. Now it is pretty straight up and down, so now the cutter is on center. Another way to test it is this way. We're going to turn it on. We're going to make a cut. And now as this approaches the center, if we're high, you'll see a little bump start to form, and then it'll normally get pushed away and you'll have a weird looking center. If it is low, you're going to end up with a little tower, a little bump left at the end. So if we stop right now, we can see, we zoom in, there's a little bump right there. We take our ruler, it's hitting a little bump. So we know we're low, so we can then just repeat this process of raising it up a quarter of a turn and then recutting. And to see if we're even close, we can manually try to take it away. There's still a bump. And I think we're pretty close, so we're going to make another skim cut. And it should produce a perfectly smooth surface. And we can now see that if I run my ruler across there, there is no bump. And we have a smooth surface, and that means the cutter is now perfectly on center. Thanks for watching. We'll see you in the next one.